Welcome to another video on my monorail built with fischertechnik and controlled by a fischertechnik robot interface and ultimately the BeagleBoard Classic running Ubuntu Linux and connected to the interface with a USB cable. This is a probe belonging to an oscilloscope, and this is the oscilloscope currently set to pulse, and the idea is that this whole monorail where this is the power rail, this is the power rail and that is the ground rail. Everything is powered or controlled by pulse width modulation, and last time that was a bit of a error because I was measuring volts and not a pulse width. So now, hoping that everything is set correctly, with on this side the ground, which has to stay connected, of course, and the ground crocodile beak from the probe, and that way I am hoping to catch the problem why it at times does not run. So going to the computer and pressing enter to start running, programmed in Python, but so far not much is happening. So and actually, yeah, nothing's happened. But it's not running as fast as possible. And I press just a little bit, just like last time. And it's hoping that it actually runs. And that it runs further than last time, and maybe hopefully faster. But another problem is, of course, that I'm releasing it now, and there it goes, softer and softer, or slower and slower, and as long as I squeeze, things run a bit. Now this probe, this rod is passing from this rod to the other, well, rail I should say. It is now exactly on the end of on the passing from one rail to another. And it doesn't do much anymore. So I think with this is an excellent opportunity to shift it back where it came from and take a look at the oscilloscope, whatever it does with respect to pulse width modulation, because that is how it is controlled, and maybe it explains why the speed changes, although this is, I don't think this is anyway explainable with pulse width modulation. you'll hear the difference in speed, but no, there's no change. Anyway, time to measure. So right now we need to have a look at the oscilloscope, and unfortunately the angle is not ideal. So let me try to change this. See if this is better. Hardly, but now you can see a broad band that is here, and I need to bring that down. Alright. But now you can see that the position is not quite what it should be. So the question is also now how to bring this back to a nice line, but also what happens when I stop the program from running. This happens now. So I'm starting the program again. So there is definitely something, and maybe just playing. Well, if it is pulse modulation, what frequency? 200 Hertz is with a period. What 1 divided by 200 is 5,000 maybe. So let me say 5 milliseconds. Not really. Microseconds. Just trying. It looks like I need some more better setting to measure, to get a real nice graph of it. Because in the meantime, this isn't doing anything either. And all I do is squeeze the rail. So whatever is going on, it apparently has something to do with the pulse width, because otherwise I wouldn't see anything right here. So I'm going to check this setting
and see whatever it comes. Sounds like a good idea. Alright, so now you see something completely different. What I did do was indeed using Maxima, making a simple transition to 200 Hz, which is indeed per period 5 milliseconds. However, here the different view is because I changed the time base. So on the right side here you can set the vertical and horizontal settings. So let me just keep this setting for now and see whatever happens when I once again squeeze this stuff. Now the propellers are still, but clearly things are still going on. But well, it looks like that when the propellers are still, that there is some mechanical vibration missing. So, but apart from that, can I make it move again? Shifting everything there. Now it's completely to the end. And mind you, I'm not even paying attention to all this output because that is not changing anything. You can see the light. All the lamps are burning. And from this output you see that that they are all working. The sensors. So the question is, even when I do this, what's going on? Everything is still measured. Now it connects. So I do wonder what this means. And now what I notice is a change in speed of the propeller, and the waves are shaking a bit. So it's not the squeezing that it notices. Because right now the propellers are varying strongly in rotational speed. with a little bit of squeeze of the rails, and you see immediately the change in the oscilloscope signal. However, it doesn't drive. It doesn't ride at all. Does it now? Just a little bit. Now it starts driving. And the slow driving has no influence on how the wave form looks. Come on, drive a little. Right, I need to see how this ends up. Now, one thing is that this setting is for 200 Hz, and the range would be 100 to 200 Hz. So a quick calculation: 1 divided by 150 is 6 repeating. So let's say decimal 0067. So let's do that, because now the carriage stands still. You can see that the propeller is not moving, and we have a very stable signal. Well, stable enough anyway. It's not a fluent curve, but let's change things anyway. So 0 decimal 0 6 7 and of course seconds. Would it make a difference? Sorry, I doubt it, but let's just see whatever happens. One thing is, of course, that this probe is just at the end doing nothing, just registering and measuring the signal that you see here on the display. And right now there's no change in behavior. Not that I really had expected one, but also last time I parallelized these tracks, but that hasn't led to any particular change either. So kind of maximum speed. But does it run? Yes, it does run very slowly. By no means the large speed that I want. Holding as still as possible. So if you look at that signal, it's remarkable is that mechanical vibrations through it. I doubt it, because what I do here is not being registered on this side with the probe. This probe is just standing still, yet this is what it measures. It is just measuring the end at the end of the track. So what can I do about this to figure out if it is here as well? Yeah, use another probe. That's the only thing that could be done. But is it any use? That is a very good question. And I think I'm going to attach a probe right on top. So right on top of here, another probe, to see what that registers.
Now I have put the probe just plain on the carriage with the mass crocodile beak here and the probe itself here, and well, although the wiring is completely routed there, you can see that it is exactly the same wave. And then I'm talking about the blue color, which is the second probe. Now I also measured with the probe right here, which gave exactly the same waveform. So in that sense there is absolutely no difference, which I also did not expect. But now when I change here a bit, then unfortunately the weight of the probe is acting up. But right now you can see that it moves, although very slowly, but it did move. And another thing is, let me put it there. It moves slowly, but there's no difference in waveform. And there it goes again. So the weight of the probe influences things, but only mechanically. So the waveform, as you can see here, does not change at all. Which does raise the question, if you look at the tracks, with the probe here, this probe is probing for the yellow waveform. Then what causes the whole thing to change speed? That is not clear to me. So let me lose the probe here. Taking care of everything. Alright. Now I am measuring here. and then measurement on the scope, losing, making contact. So losing, anyway, that's what I want to show. The waveform stays the same no matter where you probe, and that's remarkable considering the lack of speed right now. So what is the cause? I don't know yet.
One other thing that I'm thinking of is that with pulse width modulation you expect a block wave and not some kind of sine. So the question is this really pulse? Well, yes, right here it says pulse, and right here, oops, yes, two cameras next to each other. Anyway, with the mouse then, here I have a period and I have width, plus width, minus width and frequency. And the question is, with a period installed and width, you should have all covered, and then again having here pulse, two channels, and the one, well, with the pulse width set it, apparently this shows pulse width, and I do not really get it. So now by manual control alright, let's conclude this. Measuring pulse width looks nice, although it is not block wave what I'm detecting, but that may be me not setting everything correctly. For instance, is this indeed set correctly? When I do this, it is a positive wave or negative. What does it do? Right, do I get something different? Could be. I don't get other block waves. So let's stick to this one, and I'm completely off my setting. So let's stick to 600 and to 6 decimal 5 milliseconds. Anyway, a step closer. If you like this video, please subscribe and like my video, please. Subscribe and like. If you do not want to subscribe, you can always like, but also follow me on Twitter if you can do that. Also, you can follow me on Instagram. If not, please visit my website, weekly published blog, and you can find a lot more info on my website as well. Please donate to keep everything coming. You'll find a link to the donation page on my website. And what can I say? This is going to be continued for sure. Once again, thank you for watching. Bye bye.